This lecture is for Stony Brook University, Seoul, Korea, ESE 1-3 preparation of midterm 2. So this is the sample exam of ESE 1-3, and this questions is all composed by myself. So yeah, please remember that, and let's get started. Okay, the first question is about just simplifying the following circuit diagram and answer the questions that follow. This is a very basic question, right? Yeah. So there is some kinds of values. The resistance values, and there's a very complex. Actually, this is not a complex circuit, but I draw it very weird, so it looks just like a very complex circuit. So don't be afraid about looking at these kinds of things. Okay. So first, let's simplify this circuit. To simplify it, we should distinguish the series and parallel, right? So I will just draw a line at the parallel and series. I'll draw the blue line at the parallel and the red line at the series, okay? So, yeah, this is parallel, right? This is series. This is series, right? Actually, this is also a series, right? And this one, R5 and R4, are parallel, right? Okay? But R4 to 5 and R6 and R7 are just series, right? So these are parallel, right? But this is series, right? So please take a look at it. Also, this part and this part is parallel, right? However, there is series like this, series like this. The whole part of this resistors and R14 is series, right? Okay, that's all. And there is just a resistor alone in here. And this is also a parallel, 3 parallel resistors. And again, just a lone resistor, okay? So, if we change this drawing as a very simple drawing, we can change this drawing as this way, okay? So let's match it. First, here will be 24 volts, and here will be just the ground, right? Okay, so this is R1, this is R2, and R1 is 1K, R2 is also 1K, R3 is this one, and R3 is 500 ohms. Here's R4, R4 and R5. I said this is parallel. So R4 will be, 500, R5, also 500. Okay, yeah. R6, R7, 470, and 1K. Okay, and let's go to the below. You should take a look at this part very carefully. So R11 first comes, and then R10 comes, and then R12 comes. You should think the order of these resistors carefully, because there is a question about the power of R10. Okay? So, when you're simplifying this circuit, you need to draw it straightforward, but also you need to take a look at the order of the resistors. So this will be R11, this will be R10, this will be R12. Okay? And it said this is 240, 1K, 100, and this is R13, and R13 is 150 ohms, right? Yeah, right. Okay, and R14 is here, right? And this will be R15, because R14 is connected with these bunch of parallels, right? And R15 is isolated of this part, right? So yeah, we identified it well. This is 240 ohms, and this is 300 ohms. Over here, there's just R16 alone, 200 ohms. And here is R17, 18, 19. And all of these are just 50 ohms. Okay? Good? Yeah, we just copy and paste this part. Okay? Yeah. And finally, we can find R20. And this is, 150 ohms. Okay. So, first we redraw it. This is not a simplifying. We just redraw a circuit using just a straight lines, right? Like vertical straight lines. So it looks more comfortable. Okay, now let's add some resistors. Oh, sorry. There's a missing point. This is R8. You should not miss like this kind of things. R8, R9, and this is 300, and this is 100. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, finish it. Oh, by the way, test point is here. Okay? So, let's do it. First thing what I want to do is make this as just one resistor. Also this one. Okay? So, for here, the first resistor will be R1 to 2 and 8 to 9, because I will add all of these resistors. Okay? So, if I want to add these resistors, the sum of the series is 2000, 2k ohm for R1 and R2, and for R8 and R9, the sum is 400 ohms. So the equation will be 2k multiplied by 400 divided by 200 for 2400, right? So I already calculated this value, and the value was, oh, it's hard to read, right? Oh, let's just write this. 333.3 ohms was the first value. And next, let's just left our 3 as 500. And let's add this, add let's add these resistors, so it will be just 250, right? 250 ohms, it will be R425. Okay, finally, there is a two series connections. One series connection over here. So let's just add these two resistors, and it will be R627,470 ohms. Okay? Okay, so we simplified it from R1 to R9, right? Now let's move on to the bottom. At the bottom, first I want to make simple over here, yeah, because in all these parts, the most complex part of the bottom of the circuit is this part. Do you agree with it? I hope you will agree with it. So I want to simplify here first, okay? Okay, so if we add R10 to R12, it will be 1,340 ohms, right? And there is also R13, which is 150 ohms, right? So if we add these values, the value for R10 to 13 was almost 135 ohms. Okay? And let's just left our 14 over here. So we can just left our 14 over here, and our 14, and it's this one, right? And our 15, yeah, we didn't touch anything about our 15, so let's just left like this. Okay, good. And there's our 16 over here, let's just left it. And let's simplify these parallels also. Okay, so if we simplify, first it will be 25 ohms, and it'll be a parallel of 50 and 25 ohms, right? So if I calculate that again, it will be 16.67 ohms for our 17 to 19. Okay, good. And finally, there is just R20, which is 150 ohms. Good? Good. Also, keep remind that here is test point, and let's just write that here is 24 volts, and here is also GND. Yeah. Some professors think that drawing GND in all of these simplifying diagrams are very important, so please don't forget drawing G and D in all of these circuits. Okay. Okay. Now we can simplify it more. We can just simplify all of these resistors, right? Because we can just add it, right? So the sum of these values is 2553.3. Oh, it's hard to pronounce it. 2553.3 ohms are 129. Okay? And at the bottom, we can calculate these things, right? First add these two values. If we add, it will be 375 ohms, right? And there will be just 300 ohms. And if we calculate these parallels, the values will be... Oh, let's calculate that later, okay? First, let's just add these two things, okay? It will be 375 ohms and R10 to 14. And here is R15, and R15 is just 300. And let's just add these things, because as same as here, this is very simple series resistance. So we should just add these values, right? So if we add these values, the resistance is 366.67. So 366.67 ohms. Okay? It's 16 to 20. Also, don't forget drawing G and D, and here is... Yeah. Good? Good. Okay. So let's simplify this part, okay? Let's just copy and paste these values. I don't want to write it again. So I just simplified this parallel. So the simplified value is 166.67. 166.67 ohms. Okay? This is 10 to 15. Okay? 24 volts and GND. Good? Good. Okay, we're almost done. I think we don't have to add these values. Let's just ignore this schematic and let's just add all of them. If we add all of them, the final equivalent resistance is 3086.64 64 ohms. Okay, and here is just 24 volts and GND. Good. Okay, we've finished simplifying the circuit. Now what we need to do is calculating the total current. Okay, so I'll use a different color. The total current can be calculated by the input voltage over equivalent resistor's resistance. Okay, so the input voltage is 24 and the equivalent resistor's resistance is this one. Okay, I don't want to pronounce. right? Okay, good. And I use a calculator, and it says that the answer is 0.0077 ampere. I don't want to write like this, so I will use milliamperes, which looks much, much, much better. Good, good. Okay. So, what was the first question? Oh, we already finished the first question because it was simplification. The second question is the calculating the voltage between test point and G and D. So, where is the test point? Here is the test point. Here is the test point. There's no test point in here because we add all of these things. Test point is actually over here somewhere, but we cannot think like that. So we should use this circuit. Okay. Calculating the voltage between test point and the ground is meaning just connect the circuit like this way. Do you agree with it? You should understand this. So, the voltage between test point and G and D can be just calculated by Ohm's law, which use the value up here, and the total current. Okay? So, let's calculate it. Total current and resistance. So, total current is 7.7 milliampere and times the resistance for before the TP test point is, yeah, right? So we can calculate this value, and the final answer was, yeah, 1966 volt. Okay, so the answer for B is 19.66 volt. Good, good. However, there is another problem. Calculating the power of R10. Okay. I will pick, yeah, sky blue, and let's figure it out. Okay, the first thing you should know is all the current flowing here is the same. Yes, 7.7 milliampere, because these resistance are all connected in series, right? However, if there is a parallel, it doesn't works, right? So, what we should do is first find the voltage drop of this resistance and put this voltage into these two kinds of resistance. Because in parallel, this one and this one's voltage are same, right? So let's calculate the voltage for 10 to 15. The voltage for 10 to 15 was multiplied by 166.67 ohms. So I put this in calculator, and the answer was 1.28 volts. Okay? So we can use this value over here again because this one's voltage drop is 1.28 volt. Also, this one's voltage drop is 1.28 volts, right? So, after finding this, you should move over here. We can separate it once again by 1.28 volts, and the series circuit has appeared, right? So, in this case, you should think about current again. The current flowing over the R14 and R10 to 13 is same, right? So, go back to this circuit, and you should find the current of R10 to 14. Current of R10 to 14 is 0.0034 ampere, actually 3.4 milliampere. Good. Okay, move to here. So this one will have 3.4 milliamperes. Also, this one will have 3.4 milliamperes, right? After finding this value, you can calculate again about the voltage drop of R10 to 13. And the calculated value was 0.459 volts. Okay. Then let's take this value and move over here. R10 to 12, R10 to 13 means these bunch of resistors, right? So you should be careful. And what we want to find is the power of the R10, right? Okay, good. So what we should do is calculating the current of this line. Actually, the current of R10 to 12. And the current of R10 to 12 is 0.459 over the sum of this resistance. The sum of this resistance is 1,340 ohms, right? And the calculated value was 0.34 milliampere. Okay? Okay, now we can move on to the final. The power of the R10 equals the current of R10 to 12 squared multiplied by resistance of R10. Okay? So it will be 0.00034 squared multiplied by 1,000. And the final value was 0.1156 milliwatts. Okay? So the answer of question C was 0.1156 milliwatts. Okay? Okay, finally we solved this first problem. Yeah. Actually, this is not a very hard process, but this takes very long time and it makes you very annoying, so you should pay attention. Okay, let's move on to the RMS values. and peak values and peak to peak values. Actually, this is the analysis of the AC waveforms, right? Okay, let's move on. The given waveform is periodic with t equal 1 millisecond. This is meaning that the period of this waveform is just 1 millisecond, which means this waveform is keep repeating, okay? Determine the peak voltage, the peak-to-peak voltage, and the RMS voltage. If necessary, calculate the voltage. An appropriate explanation for the correct value is sufficient. Okay, let's do it. First, what is peak? 2 volts. You should find this very fast. What is peak to peak? Yeah, 4 volts. Finish it. Only you should consider is calculating the RMS values. You should not spend of calculating or identifying the peak or peak to peak values, okay? So first thing you should do is separating the waves. So I will separate the waves with triangular waves and square waves. Oh, my drawing skill is not good. Okay, it's enough. Let's just think like that. Okay, think about it. What is the formula of calculating the RMS value of triangular wave? The formula is V peak over root 3 multiplied by root duty cycle. Okay? How about the square wave? Yeah. Just V peak times root duty cycle. Okay? So what you should do is just put these values and calculating it. And the final thing you should do is integrating these waveforms again to just one waveforms, right? So what you should do is square these two RMSs and add it and take a root. Okay? Let's do it. What is the RMS value of triangular waveform? The peak voltage was 2 and the duty cycle was 0.4. So it will be 2 over root 3 times 0.4. And the calculated value is 0.73 volts. Okay? How about this one? Actually, the RMS value is derived from this formula. Do you remember? So, we can just think about the absolute value because this is squared. Okay? So we can think that the wave of the square wave just looks like one straight line. It doesn't matter. Okay? Just think about absolute values when you're calculating the RMS value, especially in the square waves. Okay? Anyway, let's do it. It is just 2. The peak voltage is 2. And if we think that the wave looks just like a straight line like this way, the duty cycle will be in this range, right? So it is 0.6. 0.6, and it will be 1.55 volts. If you cannot trust that, only consider the absolute value, then let's separate it once again and let's calculate it. I'll show you that the result is same as 1.55. Okay, think about only this part. The peak voltage will be 2, and what is the duty cycle? What is the duty cycle? Yes, duty cycle is 0.2. So in this part will be 2 times 0.2 root 0.2, right? And for this part, it will be 2 root 0.4, right? And what you should do is calculating 2 times root 0.2 squared plus 2 times root 0.4 squared, and take a root over here. Okay, if you calculate this equation, you will also get 1.55 volts. Do it yourself. Okay, finally we find these two values, and what we should do is doing the process what I just shown you. So it will be 0.73 squared plus 1.55 squared, and it will be 1.7 volts. 1.7 volts. Okay, so the VRMS is 1.7 volts. Good? Okay. I'll just stop at here, and because we spent so a lot of time at the question 1, so I will stop it here, and I will take a video about 3, 4, 5, and 6 at later. Yeah, it'll be uploaded after this. Yeah, it'll be uploaded very soon, so don't worry about it. Okay, the first lecture is over.